Lesson 9, Part 2, Question 1. Determine the null and alternative hypothesis. So the null hypothesis is 529 because that is what was previously accepted to be true, or what was assumed to be true to begin with, that it hadn't changed. And so that is 529 because that's what it says. In the second to last sentence it says the scores in the GMAT in the past have a mean score of 529. So we're going to assume that it has not changed. That's our null hypothesis. The alternative is the last sentence. The BYU professor feels now the score has improved within the last couple of years. Okay, so that is why it's the alternative hypothesis is mu is greater than 529 because that's what the professor wants to test. B. Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or a type 2 error committed? Okay, this is a type 1 error because you rejected what was true. You rejected the truth. And so you thought that it actually had improved, but when in reality it hadn't. And that becomes pretty dangerous. So that is committed a type 1 error, rejecting the truth. Part C. If the analysis was done at an alpha level of 0.01, remember alpha represents the level of significance, what is the probability of committing a type 1 error? And the simple answer is it's 1%, or 0.01. Your alpha level, or the level of significance, is the probability of committing a type 1 error. D. If we want to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? Okay, now, the level of significance, remember, is the probability of committing a type 1 error. So if you want your probability of committing a type 2 error to be low, your level of type 1 has to go up. It's kind of like a balance. Okay, as one goes up, the other goes down. As the other goes down, the one goes up. Okay, so the probability of making a type 1 error is inversely related to the probability of taking a type 2 error. So if you want to decrease the probability of making a type 2, you'd have to increase the level of significance. Question number 2. Design a study. What is the population from which the realtor obtains his data? How did he sample his population? And what is the research question? Okay, so first off, the population. Where did he collect his data? That's your population. So he collected his data from the second home buyers. How did he do that? Well, in here it says he just did it randomly. He randomly selected. In the next question, we'll talk about different ways that he could have randomly selected from his own clients. The research question is the average age of the people buying second homes in his area, is that different than the average age of people buying second homes on a national level? Okay, remember your research question is just simply what you're trying to find out. If you want to find out if body temperature is different, then ask that very question. Is the average body temperature at BYU Idaho different than the average body temperature of humans in the world, or something like that? So it's just what you want to find out. Very simple. B, collect the data. Name at least one way the realtor could have randomly selected his sample. Okay, so there's lots of different ways he could have done this. He could have listed all of his clients in an Excel sheet that numbers them, and then he could have gone to a random number generator and selected a random number and picked out maybe, he said 15. He could have written them all of his clients down on a piece of paper, and then he could have cut up the pieces of paper, put them in a hat, shaken it, drawn it out. Lots of different ways he could have randomly selected. Part C, describe the data. Graph the data on a histogram, sketch the histogram below, or cut and paste your electronic copy. Okay, we're going to show you how to do that on Excel. If you open up your quantitative descriptive statistics and then type in the data here in the left-hand column, make sure that you're on the histogram and descriptive stats section down here at the bottom. then it automatically generates the histogram for you. So you can copy and paste using whatever snippet or whatever tool you have on the computer to copy and paste information there. And then also your numerical statistics are right here. So those are the answers for that first part. Very simple. Part D. Check the requirements. Since there are only 15 pieces of data, what we need to do. Now remember, if there are less than 30 and we don't know if it comes from a normally distributed parent population, then we have to make a QQ plot. So the QQ plot, well, I'll show you how to do that on Excel. So over here on Excel, on the same document, the quantitative descriptive statistics, as we did the histogram, there's another section right here at the bottom called QQ plots. So you select the QQ plots, and we'll copy our data, and then we will paste the numbers in there. Make sure to paste the numbers and not just the information. Now you'll notice that the QQ plot right now looks really scattered. But one really important thing that we need to do is we need to organize it from lowest to highest. So you come over here to sort or filter, sort from smallest to largest, and there you go. You have the organized QQ plot. And there again, you can copy and paste or snippet or whatever it is that you can use to get that image into your document. Okay? And then remember also that if the way that we determine whether the QQ plot is, whether it represents the data is normal or not, is whether the data is in a linear line. State the null and alternative hypotheses. So our null hypothesis is, remember, the status quo, or what is assumed to be true. And we're going to assume that his area is no different than the national average. And so the null hypothesis is that mu equals 47. And the alternative hypothesis is that it's just simply different. We want to test to see if his age group of clients is different than the national average. Now remember, this is a two-tailed test because we are wondering about both sides. We don't care if they're younger or older, we just want to know if they're different. And so again, the two-tailed is represented by not equals 47. Part 3, we'll use a level of significance of 0.05. And part 4, compute the test statistic. Write the formula to be used. Okay, so we're going to be using the z-score here. Now remember what our z-score, let's review what our z-score is real quick. Z is equal to x bar, which is the mean of the population, or the mean of your sample, minus mu, mean of your population, divided by sigma, which is your standard deviation, divided by the square root of n, which is your sample size. Okay, so let's fill in these pieces one by one. As we saw in our Excel sheet, the mean of our sample was 46.93. Oh, excuse me, 46.73. The mean of our population, now remember that's the mean of the whole United States, we know is 47. We know that our standard deviation is 5. And we divide that by the square root of 15, which was the sample size. And when you type all of this into your calculator, you come out with a negative 0.2091 is your z-score. Okay, part 5, compute the p-value. Okay, in order to compute the p-value, we need to come to our normal probability applet, which I'm going to show you a real quick reminder how to get to that. So you go to the BYU Idaho wiki for statistics, which remember is at statistics.byuimath.com. And come to resources, and then down under statistical tools, you can see the normal probability applet. Okay, now what we have on our normal probability applet is our area, which represents the p-value, And remember, we are looking for a two-sided or two-tailed alternative hypothesis. So we're going to keep both sides shaded and then plug in our z-score, which was negative 0.2091. Hit enter, and we get a p-value of 0.8344. All right. Part 6, compare the p-value to the level of significance, or the alpha level. Do we reject the null hypothesis or fail to reject? Okay, so let's write this up really quick so that we can see what we're going to do. So before the test, we chose an alpha level of 0.05. Okay? Now, after the test, we found that our p-value was 0.83. Now, our catchphrase, I'm just going to write it one more time, is if p is low, reject the null. Okay, so this is our test. So if the p is lower, then we'll reject the null, but 0.83 is not lower than 0.05. It's way bigger. So we are going to fail to reject. Fail to reject the null. Part 7. State your conclusions in terms of the alternative hypothesis. And this is as it says. We just simply have insufficient evidence to conclude, and then you always just restate the alternative hypothesis. So because we failed, we say there's insufficient evidence. If we had rejected the null, then we would have said there is sufficient evidence. But in this case, we have insufficient evidence to conclude that the mean age of people buying a second home is different in the one man's area than that of the national average. So we didn't have enough evidence to say that. E, take action. What action, if any, do you suggest the realtor take based on your statistical conclusion? Okay, so I recommend he not take any different action than what he's doing. He can continue to advertise to the 47 more or less age group of people.